to show you a vector subtraction. To understand vector subtraction, we're going to use what we already know, and that is vector addition. And that would be the relative velocity example. Let's say there is a downstream current, and the downstream current is 8 meters per second on the river, right? So a man wants to come home on the other side, right? The man thinks that the shortest distance between these 2 points is always a straight line. So the man, of course, wants to swim at a straight line. And if he does swim at a straight line, what happened? The water in the river is going to push him to the downstream, right? Okay, push him to the downstream. So he swims at 10 meters per second, and the water in the river is going to push him downstream at 8 meters per second. This is 30 meters per second. C squared is equal to A squared plus B squared. Alright, so C squared is equal to 13 squared. 10 squared plus 8 squared. Alright, so C is equal to 13. Alright, so C is equal to 13. Alright, so he will never end up at home. He will end up at the, of course, downstream. This is downstream, that's where he ended up. He wanted to go home, but that's not where he is now. Learning from his mistake, he changes his strategy. Instead of moving with a straight line, now he wants to move upstream so that the x component of his swimming will be cancelled with the x component of the current in the river. So now he moves this direction, right? And the x component of his swimming would be cancelled with the x component with the water in the river, right? So now we're going to draw a parallelogram. So to draw a parallelogram, what we can do? We're exactly going to move this one over here, right? And move this one over here. So this is our parallelogram, okay? And so we're going to draw the resultant, and this is our resultant. Okay, so this is, don't forget, this is 10 and this is 8. This is 8. Okay, this one cancel with this one. So what survived? Only this one survived. Only this one survived because this one, remember, this one cancel with this one because this and these are opposite. So they cancel with each other. So therefore, this one initially had 2 components, 1 and 2, right? This one initially had 2 components, right? Right? That's right. That's right. The blue one has 2 components, right? Only the red component survived. This component cancel with this component, right? Okay, good. Let's put them back. Let's put everything back. Hopefully. Okay. So this is vector subtraction, and now we're going to put it back. Plus b squared equal to c squared. A squared is equal to c squared minus b squared. So a squared is equal to c squared, of course, is 10 squared minus 8 squared. So a is 6. So the resultant is 6. Of course, you can use law of parallelogram and law of cosine, and that both gonna give you 6. To use law of parallelogram, use r squared is equal to a squared plus b squared plus 2ab cosine angle. So r squared is equal to 10 squared plus 80 squared plus 2, a is 10, b is 8, and cosine is 143. So this is 143 because this is 37. Alright, 143. So r is, of course, 6. This is law of parallelogram. Law of cosine, r squared is equal to a squared plus b squared plus 2ab cosine angle, but make sure it is negative. I want to put more emphasis on this one. I put positive just so that I gain your attention. So r squared is equal to a squared is 10 squared plus 8 squared minus 2, 10, 8. And cosine now, of course, 37, so r is 6. So there are multiple ways of doing the law, the vector subtraction, but Pythagorean theorem is the most easiest way.